Thanks so much for the invitation, guys. This is a clear today, but previous to start, let's dedicate one message to a friend. So when I mention car, you say happy, okay? Car, happy. Car, happy. This is a GTA Grand Theft Auto with rappers, crackers, rappers, and real gangster. Car, happy. Car, happy. Welcome to this amazing event. Thank you for Isabella that invited me and told me about this event. So that's the reason that I submitted a paper. And she cannot travel to here. That's the reason that I dedicated this talk to Isabella. So go ahead. I am independent automotive security researcher in my free time. So I report vulnerabilities to Kia Corporation, Kia Color, Suzuki, Huawei, Cali, Riate, and I have surveillance in cars. But in my work is like bad hunter and hacker one. Anyway, I am a member of the car hacking groups of DEFCON, founder of some interesting things. And go ahead. So this is a HAD unit, Kia HAD unit. Maybe many people here have Kia HAD units. So the model is this one, the HAD unit FCCID. If you want to improve the research, you want to explain more about this, you have all the information, the firmware, the software, and so on. So pay attention here to the system of a chip. The system of a chip TMN9220 is the system of chip that controls everything. Here we have the CAN microcontroller N66 for the people that execute our research in this kind of thing. This is a very older CAN microcontroller. Also here we have 2 flash and also one EEPROM, okay? About the system of a chip TMN9200 manufactured by Channel, we don't have any more information than this one. I was Casey to the manufacturer about the datasheet, but I don't get any information. Anyway, here we have the supply chain. Tam will create the system of a chip, MITRE use this system of a chip, vulnerable, and put in the HAD unit, and finally this is supplied to Kia, okay? When you dump in the EEPROM, we have here configuration information, also system information like the UUID. And in the boot process, remember, I'm going to focus in the bootloader process. We have traffic between the system of a chip and the EEPROM, okay? The next one, the SPI flash 2 megabytes. When I sniff the boot process, I don't receive any traffic. So I discard this for study, analyze the boot process. And when I put a logic analyzer in the second SPI flash with 16 megabytes, I have traffic. So in this case, here we have the bootloader, the second stage bootloader, because remember the system of chip has the root boot, but after that we have the second stage bootloader. So this is to SPI communication. And in the backside, we have the UR access. And this was very useful because I was able to get a shell with read permissions, and I discovered many functions of this operating system, okay? So go ahead with binary parsing this real-time operating system. Remember, this is no Android Automotive OS, this is no Linux Automotive OS, this is a new real-time operating system that I discovered in this research. In the binary parsing, Big One was not useful, remember, for reverse engineering hackers. Big One is a ship, so I need to execute a manual analysis to these kind of things. For example, MySQL, copyright, and this PNG, I don't retrieve 100% correct with Big One. That's the reason that I execute this with Python script looking for the correct magic bytes. Okay? As you can see, this is very dangerous. Why? Because the Bluetooth information is in plain text. Here we have the Bluetooth password in plain text, the contacts of the Bluetooth connections in plain text, and also the information in plain text. Google this. This is a friend of mine who is in plain text. Sorry about this. And also, there are very famous real-time operating systems called QNX. And Big One told me that this is a QNX bug, but again, this is a false positive, as you can see. Because if you visit the Big One version 2, GitHub, you check the signature of the QNX 405 system, EB109000, okay? But what is going on? If I visit this signature, I realize that these bytes are corresponding or regarding to the ARM thumb instruction BLX that it is regarding to the function, okay? This one here. And also I recheck because if we check the address 2D6572, I discovered the same address in the same offset, what I mentioned, the call to this function. So basically here I don't have any QNX in block processes. So this is not a QNX. What is the name of this real-time operating system is IRTOS, because if you visit the manufacturer webpage, we have Android, Linux, and IRTOS. And also you can recheck about that in the firmware, because in the firmware we have a string about the path and about the IRTOS, as you can check here. So yeah, after a lot of reversing process, I discovered all of the firmware IRTOS parts. So in the first part, we have the recovery bind, compressed in RR file. All this in RR file. This is the factory reset. The next part is the RR file 2 that have the second phase bootloader, and the name is premain16.b. Another one is the RR3 file with the main real-time operating system. Here we have the kernel, the file system. Here we have the chip, phase bootloader, and also the PNG files that appears in the bootloader process. Okay. Firmware firmware version, and also the Bluetooth data that it is in plain text that you previously checked that is in plain text, also the password, the name, Bluetooth connection. Pay attention here. Here we have 882 PNG files. And what's very dangerous because all these images of the high unit are in PNG files. All the arrows, the numbers, the lights, the seats, the home screen logo. And you can see the numbers. Here we have the images that appears in the boot process. All are PNG files. More reversing 110 tags identified at the moment, but the principal task is in the main binary. This is the main application task. This is the task that run like a loop in the real-time operating system. What do these tasks? It's the central process, after initialization, the function enters in a while infinite loop. That address, which is typical for real-time operating system, binds the task to keep the task alive and responsive. Inside the loop, it checks the system flags and state process events, log the status, and calc various systems, handlers, audio, MCU. So periodic checks, ensure the system remains responsive, and so on. But here's the key about the vulnerability. Here we have the PNG functions. This real-time operating system has a lot of time PNG functions. So I was discovering that these hundreds of functions regarding to the PNG functions are regarding to the libpng C library. Maybe someone discovered a critical vulnerability in this library, libpng library, okay? So I discovered that all the functions are regarding to the libpng library, so I create a table and I correlate the function that I discovered with the function that is in the libpng documentation. At the end, here we have all the technical information, architecture ARM, processor Cortex A9, firmware, there was the C, the SDK version, and the libraries version. And these libraries are vulnerable, have already CVE reported. So, yeah. Go ahead with the vulnerabilities. The Bluetooth also is a password. The Bluetooth password is in plain text in the URL logs in the boot process. Here we have the two private keys recorded from the firmware. So this is danger. Private keys in the firmware are burned. So pay attention to that. Matrix libraries vulnerabilities, like PNG vulnerabilities are already reported in the version 1.2.29. And so go ahead and analyze the bootloader. Okay, remember the part we have the firmware divided in rare parts. So I will just check the integrity process in this high unit. So I recompress the pre-main, the second stage bootloader with version 4 because the firmware use version 4. I don't know why don't use a version 5. Okay, I create a Python script to create the firmware and I test the second stage bootloader and it works. So at this moment we have a white screen. Okay, so don't get up. Let's test it more. So At the moment, the root boot is okay. You know, the first state bootloader, the signature, the crypto key, and the integrity process is 100% bad. But what about after the second stage bootloader? And here I discovered a fake. So first of all, the root boot load the pre-main binary. The pre-main binary is the second bootloader, and the pre-main binary load the final real-time operating system. What's going on? Oh, okay. Thank you so much. And finally, here we have the final real-time operating system of the 882 PNG files. But here we don't have integrity, and I'm going to show the line of code that appears the vulnerability. So it's not useful if we have a secure bootloader, but at the end of everything, we don't check the 882 PNG files. So this is the functions that are held in the pre-main, in the second stage bootloader. You know, detect the flash device, the manufacturer IDs, device ID detection, the GPI monitor main, and so on. Here appears the logo of the Kia logo when you power on the hard unit. This is the principal types of my real-time operating system task. Okay, first of all, hardware information. Flash detection, memory use logs, print and map. And here in the line 4 we have plain main types real-time operating system where the file system is mounted. Okay? And after that we have a lot of types about the configuration, Bluetooth stack, serial transfer programming, phone book access, touch screen controller detection, and so on. It's like analyzing a big real-time operating system with hundreds of millions of lines of code. Okay? But this is a summary of that. And finally, here we have in the function main application tags, we have here the log that print in the UR console that mention that the file system is mounted. Okay, but what is going on here? If we check in the tag, the application, you know, the UI demo issues a standard file open class through the operating system, okay? So the operating system reads the raw PNG bytes from the flash into the main memory, the DRAM that I showed previously in the board, in the electronic contributor of the hardware. Via the system of chip memory controlled and boot farming, okay? And the PNG library parses headers, the compressed e-data chunks, and produce uncompressed RGBA buffer interrupt. But what is the error here? The error here is that libpng checks are useful because libpng only checks the integrity into the image, the e-data chunks, the headers, the integrity of the headers, but libpng don't check the integrity of the entire image, the empty file of the image. Okay? So I used to do a very funny defacement proof of concept, and I would use the hack word in the home logo, and I create the new firmware. You know, have another hash. So you can start with A3 and the original hash of the firmware start with 26. And voila! What we have here, the hack word. And this was the proof of concept that this integrity process is not okay. It's not working 100%. So go ahead and create the most elaborate pure phishing in the automotive cybersecurity world. And after many file attempts, I discovered the backdoor requirements. So the fake image must be the same size as the original image. If the image is smaller than the original, padding with zeros is an option. The image will not render if it is compressed due to the live PNG checks. Remember, it is possible to replace any image as long as the same offset is maintained in the firmware. Here we have the original QR direct to the official Kia webpage. Here is the official Kia webpage, Kia.web user manual, and so on. And I created an escape with all the factory requirements. The QR phishing attack. At the end, this tool is public. I invite you to check. Here also, if you want to improve the results, is the firmware. So it's hardware TOS. Here you can create the firmware, create the backup firmware, create the malicious APIs that I'm going to show in a few days. And here It's a proof of concept that I create everything. And as you can see, I create a fake web image here, page with a button that allows the user to download a malicious web APK for Android. As you can see, the app is installed. And let's go check the demo. And with this, I finish the talk. So please the song, could you enable the song? Please only continue the song of the video. Anyway, I understand the fake QR that redirect to my web page that I set up, reverseeverything.com. And after that, I download the malicious APK, and finally I get access a shell to the cell phone, and after that I get the health location of the car through the cell phone. So this is a proof concept of the impact of this book in the second stage of the Kia units. Okay. Yeah, as you can see, you have Android, this application is Android, and Android don't detect that this is a malicious APK. So if someone wants to scan, the web page is alive. Still
scanning app inside. Okay. So before open this moment, I'm going to open the command configure that is open through metaploid. So this is the big thing, and this is the machine of the hacker machine. Okay. So here I have the temperature, the metaploid. The reverse TCP Android, listening the port 4444. Okay, so let's go. I'm going to open the application.
By the way, this is the Kia official
immediately
for error. So reversible giving error.
As you can see, I have access to the phone. So let me show you. CISA info. Android 14, and I'm going to put, for example, get UID. I'm going to down the SMS, for example, this one here, and I'm going to put in the path exfiltration with the name sms.txt. Yeah, so as you can see, I have all the SMS of this card.
SMS. The parts of this one. And also
I'm going to down
maybe
the contacts.
You will ask about what about the RCE, remote calling execution. Yes, there are probability that this can usually execute.
Yeah.
Or remember, I do that in my fixed answer.
As you can see, here we have. Okay. And one more. I'm going to record the microphone on the side.
Yeah, you can record the microphone, get the elevation of the...
I'm going to record around 10 seconds.
Get access to the cell phone,
okay.
access to the hybrid.
And the file.
Go to the tab, the health location, the contacts, and also the MSS down. You're recording the cell phone microphone and many more. Kia cars affected to please. Kia Saluto Vegas, Keep Canto, and more so. Also, cars. Usually in my country, there are thousands or maybe millions of cars with this real-time operating system. So thank you so much. This is the QR if you want to check more results about that. Thank you so much, Jis.